All right, how we doing today, everybody? Doing good? All right, how's the lectures going? Painful? Fun? Not enough work? Too much work? All right, so I had a question that someone asked me, and I think it was about, let me see, just do the following. There you go. Where I think last class we were talking about, what was it? I'm just going to make some circuit up. And we were doing some, let's just say, I don't know, what do I want to do? Call this one R, 2R, 3R. Does anyone bother with what I was trying to do right there? No? And it's solving for equivalent resistances. So one thing, and I had someone tell me about this, they're like, hey, I don't know how to find that, I don't know what's going on. And one of the things I'll tell you about resistors is they have two ports. And what do I mean by two ports? So if I were to draw a resistor right here, right? You got one port right here, let's call it the plus, right? You can punch something in there, right? Correct? Then we got this other port, I'm just gonna call this one minus, and it's got another port. 2 points of contact, right? And then the current goes there, and then you got your I, you got your plus minus V, right? Is it all clicking? It's all good? Great? Anyway, so someone was saying, okay, I'm just going to look right here, and some people draw their eyes like this, and I want to know what the equivalent resistance going into that terminal is, right? Is that good? So the first thing is you would start looking at, okay, what's connected? What can I easily start solving for? So one of the easiest things you can see is this resistor right here and this resistor right there, and how they're connected by just that node, right? If I were to have the water flow go down like this, and it would flow down like that, right? What do you say about these two resistors right here? They're in series, right? And now let's not solve that. Let's do it another approach. We have this resistor right here, right? It's connected over here, right? But what else is connected to that? That resistor right there, right? What about the other side? It's connected to that one. What can we say about this node and this resistor and these two resistors? They're in parallel, right? Right? Because we're looking at this pool of water. I'm gonna use a lot of water references in this class. You guys like that? Where if I have a pool of water, I'm just gonna draw my pool. It's just a nice pool, just dancing in the pool, yay. Right? And I'm just chilling there, right? I'm just there. Does that water leave that space? It's just there, right? It's just a node, right? I just exist there. It's a voltage V1, whatever, right? And then I have another pool pottery right here. I'm just gonna, I don't know, make it a longer pool, and maybe he's got two friends, right? Just chilling there. They're just existing. There's a V1 and a V2, correct? So now, here's the question that I got asked, and they completely forgot their fundamentals, and they're like, well, let's say if I do the following. Use pink marker, because I like pink. It's gonna do the following. And I'm just gonna short this. Right? Correct? So what happens when I short that? This pool of water right here, right, is connected to that pool of water, right? So if I have a water pipe just going in, right? Oh, path of, let's just do path of least resistance, right? It's going to want to follow this line right here, right? Is that correct? So if I were to try to solve for the equivalent resistance of this, right? I'm going right here, right? I'm walking the circle, right? I'm walking, right? And I want to go the path of least resistance. Am I going to go down here? No. Am I going to go down here? I don't know, maybe. See this short? I'm just shorting, right? It's going to go right through that, right? So let's rewrite this circuit and show you what's going on. Two. Boom. If I had a resistor and I just short it, right? What's the equivalent resistance right there? Yes? It's just 0, right? It's just a wire. Is that difficult? Easy? Not easy enough? Too hard? Any questions about that? So now someone's asking me, hey, I want to solve this in LT Spice, and that's a great question. Let me see. LT Spice. Someone wants to prove everything we're doing. Let's just do this. Just do that. Do that. You guys like how I'm doing this fast? Don't worry, you'll be masters of it. Maybe you are. No worries. Let's do, I don't know. Should we do 1, 2, 3? Right? Is that a good number? So, what's one thing I'm going to show you? Let me show you this. Oh, I clicked the wrong button. Remember how we have our voltage source? Let me use a different color. Go back to blue. Right? We have a voltage source, right? And we have a 1 volt source, right? Is that correct? And I have my resistor R, right? And then I have a current, correct? What's the voltage drop here? Right? How do I solve for that resistance given the voltage and the current? Let's just say this was like 1 amp or something like that, right? Is that correct? So here's what I'm going to try and do is we're going to play with this circuit. And let me see how am I going to show you this the easiest way possible. I'll show you. Let's try this. Let's try it much easier. Let's just do this as 100. Boom, boom, voltage. Let me just check my sanity. Check, check. You never know. How was the video? Was it good? It cut off last week, but did it play right? All right, perfect. So let's try this. Let's see. If I were to throw in a voltage, let's do 1 volt, right? We like our ground. I call this one VN, right? Is that correct? Now let's run this circuit. I'm going to do a transient, right, of 1 second. Let's measure our VN. 1 volt, right? What's our current? Let's double click. And let's click. Let's do the even double analysis. Pull this little puppy right there. Does that look good? About 10 milliamps, correct? So now, actually, let me show you this. If you right click on this plane, you can add a plot plane above or below. And now you get these 2 little planes. If I click here, click VN. I like that. And then right click that because colors. That makes sense, right? Well, let me add another plot plane. Below. Yeah, let's go. There we go. So what I'm going to show you guys is, you know how we said that the resistance, right, is equal to the voltage over the current, right? So I'm going to mathematically do this in LT Spice. I'll show you what I mean. So you can also do mathematics in these lines. Let me just show you with a smaller plot. Actually, do I want to? So you know that this right here is called VN, right? It's a voltage, and then the, what do you call it, the word in it is VN, right? Where is it getting that VN? From that label, correct? So we got right here, we got I, right? That's current. R1, what's R1? Does that make sense? Now let me just show you something. R, a load, I don't know. There we go. I'm going to do the following. Run. Oh, it's gone. What happened? Let me click on this. Does that make sense, what I'm trying to do? Let me just color this differently. So this is basically the nodal voltage of your circuit, correct? And then this right here is the actual current running through your device. So I want to know what this resistance is. So there's one thing we can do. And let me see. Actually, better yet, there's another trick I'll show you. See, if I click on this voltage source, right, we get the current going through this voltage source, correct? So I'm going to show you guys one thing. Stretch this out and create another voltage source. And now I'm going to do this. Let's call it, actually, I'm going to do 0 volts, correct? And call this one V, I don't know, dumb. And what I'm trying to do is I'm trying to measure the current. So you see how I hover my arrow right there? I wish I could make it bigger. And you see that big blue arrow going down? If I put this right there, you see that voltage supply? It's plus to minus, right? The battery's got plus to minus, correct? The arrow is going from plus to minus. What does that mean? The current is going down, right? In this battery, well, it's going counterclockwise, correct? Now if I put the arrow right here, right? You see that blue arrow, right? When you click on this, it gives you the current in that direction. We're going clockwise. Whereas here, if I click here, I'm going counterclockwise, right? I want that arrow, okay? Here's the trick. So I'm going to create a new voltage source. This is a dummy voltage source. So basically, all it does is it just exists. It's just 0 volts. It's just there. So I'm only creating this just for mathematical purposes. And better yet, I'm going to call this one current measure, right? And I want to measure the actual current. Click on it. Same thing, right? 10 milliamps, right? So now what I'm going to try and show you guys is I want the voltage here, right? Or actually better yet, this right here. Cut this out. V in. I'm taking the voltage of my battery, right? And what I'm going to do, cut, is I'm going to divide this by the current going through that current measure, right? So if I type in I, current measure, right? Look at that. Let me just zoom right there. What does that look like? 100 ohms. All right, someone's probably saying, why do I have to do that one? I'm just going to call it dumb. Yeah, there you go. You like that? So if I measure V in, right? And if I measure the current in there, right? If I do the following, divided by I dumb, right? Let me just get rid of this guy. Boom. Does that look good? 100 ohms? Right? Now, let's try this. Let's see if this is going to work. I don't think this is... It's going to work, but it's going to bark at me. Does that bother anybody? Want to see it run? Want to blow up some stuff? It says, let's see, the source... parallel, making it overdefined. Basically, it says you need to have some resistance. So let me just do the following. So you know a wire can be thought of as like a really tiny resistor, right? 001, right? Tiny resistor, right? And I'm calling this one R short, correct? There's a small tiny wire, right? We're shorting this, correct? I'm gonna run this again. What is... So I have a voltage, right? And I have a current running through this. Let's see what the current is. Oh, that's not good. 10,000 amps. Like that? Yeah, that's a lot of current. It's going to blow the whole circuit up. But what I'm trying to show y'all is you have your voltage, right? And all you do is just type this right here. I of whatever your source is, dumb. I don't know, like that. And boom. And what's that resistance? 99 microohms. You guys want to... what's the difference between the kilo ohms we've been using and this microohm? It's orders of magnitude. That's about 9 orders of magnitude. This is a tiny resistor compared to like a kilo ohm. Does that make sense? So for practical purposes, we can just say that this is 0 ohms. Is that understood by everyone? No one's gonna be like it's 0.9999 or 0.00 zeros 1, and then teacher's like, just say 0. Come on, man. I know we gotta be precise, but that's one way of doing it. So if I were to do the following, let's see, what was that resistor? Let me just do 200, 300. And I want to know, I'm cheating right now, is I want to know the resistance of this. Oh gosh, so much, right? Let's do it. Oh, look at that. It gave us the answer. 83 ohms. Guys want us to prove it? Let's go back to our thing. There we go. If I were to do the following. $100, 200, 300, right? When you add these two, what happens? $200 plus 300, correct? And now we want to combine these in parallel, right? What's that equal to? Let's see. Let's use our magical calculator. So we have 100 times 500. Nice. Divided by 100 plus 500 is 600. You guys like this? Easy? Let me just bring out this guy. 83 ohms. Anyone bothered that I didn't put 0.3333? Correct? Yes, yes? All good? Oh, what? Say that again? Wait. Oh, you don't. Oh, you want to see the 0.333? Ah, got it. Okay, let's do it. 0.333. Happy? Anyways, so someone showed me a circuit, and let me see if you wanted to. Let's go crazier. I don't know. This. I'm just in the following. You like this? Just plug and chug. Is this better than ChatGPT? Now that you know how to do it, then I'm gonna do something funny. See if anyone caught what I was trying to do. Tough, right? Let's run it. Look at that. You can solve any circuit you like. And then, oh yeah, here's the trick question. I'm gonna do a wire. Boom, boom. I'm just gonna do a funny diagonal. Yeah, you like that? Yeah, looks cool. Let's run it. Oh, didn't like that. You wanna know why? Because it doesn't like wires. So let's just replace that with boom. 10e minus 9. There we go. What does that mean? 10 nano ohms. It's just a really small resistor. It doesn't mean anything. Well, it does, but we're using it for mathematics. Look at that. What can we say what the equivalent resistance is looking at this? It's just 0. It's just a wire. Will that help you with your homeworks? I'll give you guys this file. You guys can play with it. All right? Let's save it as... look at all these classes I got to do. T20D, week 5. Call this one resistor calculator. No, wait. Equivalent. Like that. Now you can do whatever you like. Any questions? All right. So I got a question from another email. And that was about, let's see, let me show you. This was page 3. This is page 4. Boom. about calculus. Are you guys going over calculus in class? Like problems? No, not really. Because I think someone emailed me saying we got this right here. It was like it was a sine, yeah, sine of a of t, right? And this was your signal. Is that something you guys saw in class? No. No.
Class it was more like tan sine parentheses 3.
But you guys know how to solve for this, right? Easy. You guys want me to go over this, or you guys have any other good questions we want to talk about? All right, this is now where we start going into our funny territory. Chrome. Let's see. Enshi. Yes. Boom. Yes. Sign me in. You guys have to do all this verification too. This is great, right? I don't know, man. I don't know. You tell me. All right, let's click on, which one do you want me to click? This one, or why do I have like 3 sections? Yeah, let's click this one. Who wants me to click on Pushkins? No? Too hard? Yeah, let's click on it. I like that. All right, where's your homework? Ooh. Oh, you guys like that? Who wants me to give you the answers? Let me see. Not available? What do you mean? What can the student see? You as student. Yeah, you guys have a big final exam coming up. What the heck is this? Not available. What? Man, we're never going to get anything done there. Let's go over here. What? How do I leave student view? There we go. Let's go to this one. You as student. There we go. What are you guys doing in class? Overdue assignments. Oh yeah, I gotta do my assignments. Undated assignment. What the heck? What are these guys making you do? What? It was a paper quiz? Leave student view. You guys already did quiz 2, correct?
Yeah. We took our midterm yesterday.
Was that painful?
Kind of. I want to go over the answers, but you won't be able to access it.
Yeah. That's weird. Can anyone explain what is a good problem? Let me see. What if I click on? Yeah, someone give me that. I want to go over. I want to see if we can dissect this without me having it. Is that why not a lot of people show up today? We're all fried. What? Today? What incarnation?
You want to try doing this one?
Let's do it. Was that on the exam?
Yes. So I want to verify it.
Want to join me? This is our class participation. We're not doing this. Screw this. We're gonna do that. I like that. Which one's that one?
2.45.
2.45 plus minus. Man, I like this interactions. You guys wish all your other professors did stuff like this? Be helpful. You guys want PowerPoint 2.0? I can show you that. ChatGPT. Teach them that what I gotta do. Sorry, I can't do that for you. Would you like more recommendations for what to give them for homework? Maybe. All right, 6, 2, 3, 5, and then 30. And then what we're finding, open voltage circuit. Oh, all right. Find that one. All right, good. You guys want to do this one? Is this something similar? Shaking, head nods, yes, no? It's the first thing we got to do. Oh, there's nothing to do because we got to first define our reference, right? Feeling more confident? This is 2 amps. That's ohms, 3, 5, 6, 30 volts. What's the voltage over here? 30. We're all confident with that? Current going up here is 2 amps, right? Let's see. How do I want to do this? Let's call this one Vx. Is that good? So let's start defining currents. I want to define this as, let's just do, I don't know, I1. Then let's see. We're trying to solve for, is there nothing connected here, by the way? All right, I like that. So, I want to show you guys something. It's going to be, we're going to cheese this pretty bad. So, can anyone tell me, is there water going through here? Why? It's not connected unless I force a wire there, right? So there's no water going through here, correct? Yes? All right, hopefully you guys don't get mad at me, okay? I didn't do anything, I'm just here. There's no water running in there, right? Correct? What's the voltage drop here? 0, right? There's no voltage drop. So what can we say about Vx, which is right here, right? And this VOC? They're the same. Or whatever that is, open circuit, correct? So all we're doing is we're just solving for this. So this right here is just to trick you, just to see if you were paying attention or not, until we start shorting it and then we start losing current, correct? So let's do our KVL, plus, minus, plus, minus. Do we need KVL? No, because I don't like that. We want KCL. Let's get my pink marker because I like pink. I'm going to do, let's just do I1 right there, right? Current going in there, yes? The current source into a voltage source. This right here? I know what you're talking about. Well, I kind of want to try that. I think I know what you're talking about. So I think what you're saying is, here is my current source right here, right? 2, right? Ground, right? Remember how we have this right here is our 3 ohm load, right? And then this right here is, let's just say, whatever our circuit is, right? Load. You're saying you want to transform this into plus minus V, I'm going to call it VT, RT, like that, right? Is that what you're trying to do? Have you guys talked about Thevenin and Norton in your classes? Yes? No? Briefly, yes, you can definitely do that. All you got to remember is this right here is your I Norton right here, your current, right? I Norton. Okay. I guess we're going to have to go over Norton circuits because you're not wrong. That's a good thing. But will this make it complicated? Maybe. I don't know. Let's try it. 5. This is my blue marker because I like blue. So remember for, you call it I Norton, R Norton, right? To convert this to plus minus V Thevenin, right? V Thevenin is equal to I Norton divided by R Norton, right? Is that correct? Is that what you did? And then we have R Thevenin, right? What's R Thevenin equal to? The Norton resistance. It's the same. So I think I know what you're talking about. So if we go back to this puppy right here, let me see. Because I think I know what you're trying to do. Huh? It does reduce it, but let me see. Because that's a supply that doesn't change. That's a resistance that just stays the same. Because this should work. I'll tell you that. That should definitely work. But let me go over the actual walkthrough answer before we start going through that. And then we'll try to prove that without these spice. Is that good? All right, anyways. Let me just do the following. So I have I1 going in here, right? And then let's just say I don't know. Should I call it I2 or something like that? Is that good? And then right here I have my source going in there, right? Just call this one IOC. What's the current in there? 0, right? So if I wanted to do a KCL, right? The current going in, we got this one right here and this one right here. So I1 plus 2, right, is equal to the current going out, which is this I2, right? This resistor right there. Does that make sense? So what's I1? Well, we got this 30 minus Vx, right, divided by that resistor 5, right, plus 2, correct? Is equal to I2. What's I2? It's just Vx over, well, minus 0, right? Is that correct? Because we're going to ground, right? Yes? Okay. Over 3. One equation, one unknown. Hard? Let's finish this. Let me see. How do I want to do this? 30 divided by 5 is 6 minus Vx over 5 plus 2 equals Vx over 3. If I were to bring this one's bigger than that one. Does anyone bother if I do this? 4 is equal to Vx. Let me see. 5 over 15 minus 3 over 15. Does that look good? Right? 6 plus 2? Oh, thank you. Sorry, I was looking at that minus sign. And then we got this 1/3 minus 1 over 5, which gives you this right here, right? Should give us Vx times 2 over 15, right? I don't like messy work. Just block this off. 8 is equal to Vx times 2 over 15. Is that correct? And then we got 8 divided by 2 times 15 is equal to Vx. Vx is equal to 4 times 15. Is that good? Is that the answer on the exam? We don't have no idea. Darn it. Anyways, that's Vx right there. But that wasn't what we were trying to solve for. We're trying to solve for OC. Psych. Boom. There we go. You put this, he'll be like, what the heck did you just do? What is Vx? I don't know. We're looking for OC. Is that good? Now, going back to your question, because I know what you're trying to do. We are given a defined resistance, correct? And a defined current. So let's try that circuit again to where we're going to plug and chug the following. If IN over RN is equal to 2 over 3, right? 0.667 volts, right? That's our voltage, Thevenin voltage, correct? We're going to use this right here, and we already have our Thevenin, which is this right here. Let's try to solve it again. See if I'm wrong. 3, 4, 5, 6. Perfect. So, plus, minus, boom, boom. Now we're going to replace our circuit that we found. Let's see. I know how to do it. Plus, minus. R Thevenin, which is equal to 3, right? V Thevenin, which is equal to 0.667 volts, correct? This is also grounded, correct? And then this right here, this disappears. Good? And now, This right here is plus, and just do this, minus VOC. Does that feel a lot better? What's that voltage? All right, let's do this. 30, 5, 3, 6, 0.666. Right? Let's do KVL. Plus, minus, plus, minus, plus, minus, right? All right, let's walk. All right, I'm going to go up the stairs, correct? We're going to go up. We're going to go up. Going up means we've got a positive 30, correct? Now I'm right here. I'm going to go down the stairs, plus, minus, right? Minus I, right? 5 volts, right? Good. I'm at Vx, correct? But I need to know what the current is. I don't know what the current is, so I'm just going to keep going down the stairs, correct? Going to go down the stairs, right? And then actually, let's say this. That's IOC. 0, right? There's no loop. If I had a complete loop, then we would have a problem, correct? Then it'd make this problem a lot harder. But we don't. This doesn't exist yet. So we only got to do with just one current. I3, right? Now we're going to go down the stairs, right? Down by 0.667, right? Back to ground. Good? One equation, one unknown. Let's solve it. So let's do it. Let's see. Do I want to try this? Because this is 2 over 3. Let's see. 90 minus 2. Does anyone bothered by this? 8. All good? Let's see. 8I is equal to 88 divided by 3, right? I is equal to, if I do 88 divided by 8 over 1 over 3, right? This right here just equals 11. 11 over 3, right? It's just equal to, someone help me out with that calculation. We'll just keep that right there, right? I'm not going to calculate it. We want Vx. So, we have this resistor right here, right? Correct? What's the voltage over here? 30? What's that voltage? Vx, right? We're trying to solve for Vx, right? We know the current in there, right? We know the resistance, right? Voltage drop. So if I were to do the following, 30 minus Vx, right? That's our voltage drop. Is equal to I times 5, right? We know that, right? What's Vx? So let's do the following. 6 divided by, 30 divided by 5 is 6. 6 minus Vx over 5 is equal to 11 over 3. Let's see. Ooh, my math brain is thinking. Let's see. Got 6 times 3 is 18. 18 minus 11 over 3 is equal to Vx over 5. We got 12, 13, 14, 15, 16, 17, 18. 7 over 3 is equal to Vx over 5. Then let's see. Vx is equal to 35 over 3. Is that correct? Did I do something wrong? Vx of 60. I'm getting 2 different numbers. Uh-oh. What happened? Let's check. Did I do anything wrong? I went up here. Here's my 3 ohm resistor, right? That's 8. Did I do something wrong right here? Let me see. Because what I did right here, this right here is also 2 over 3, correct? Right? And then all I did right here is just 30 times 3 is 90, right? Wait, 30 times 3 is 90, yeah. Divided by 3. Then I just brought this guy, well, subtract this with this, that gives you 88. That's 8. Boom. 11 over 3, yes. What happened? How can this happen? Let's see. 30. We got the current. That's the total current. 30. That's a current, right? Minus 5. Boom. Wonder what happened. 30 divided by 5 is 6, correct? 5, 11 over 3. This should work. Wonder what happened. Let's prove this. No more complaining. LT Spice. New file. All right. Who's ready to do this with me? We're going to avenge myself. Zoom. P for parts. Current. This one's going into the node. Let's see, what else do we have here? Boom. Let's see. That should have worked. Maybe I did something wrong. What? He's wrong? Yes, I'm wrong. He can't be wrong. Let's see. 30 volts, right? Vn. This right here was 5, right? 3, correct? This right here is Vx. That's what I'm calling it. This right here is 2 amps. And this right here was 6. And then this right here is VOC. All good? Let's see if I can save myself. Let's run the answer. 1 second transient. All right. 30 volts, correct? Whew. Moment of truth. 15. What happened? We did something wrong, chat. What did we do? So we did both ways, and we still got it wrong. What happened here? 5, 3, 2. Don't worry about that one. What happened? The current going in there, right? 30 minus Vx over 5. The current going in is plus 2, right? In equals what's going out. Vx over 3, correct? 5, 10, 15, 20, 25, 30, right? Oh, sorry. No one told me that. There we go. I'm right here, right? I1, right? 2, right? I2 going down, correct? Yes?
I think you're doing the actual there, you put 5 minus 3, 2, 5 plus.
You're absolutely right. This is 8. It should be plus. Let's go. So this should actually be 8 over 15, right? All right, thank you for catching that. So 8 over 15, this is page 4. All right. This should be 8, right? 8 over 15, right? I don't like this. Let's go strict. 8, right? So now that we have that, right? And then let me see, Vx 8. There we go. That looks a lot better. Man, don't you like it when you get dinged for one little mistake? Yeah, sucks. So what happened? That one was correct. That one was understandable. But what happened here? I would have assumed this should have worked. Should have. Because we have this current source. And I think I probably know why. Because this right here is a circuit, and you want to plug this back in. Give me a second. Because this is usually not how they teach it, or they could. Because this is right here, the That's right there. This is Vx. This is the whole load. This right here is my load. B is equal to I over R. Oh! Thank you. That was what I needed to hear. Oh God, you see, sometimes I have 20 billion things in my head and I keep forgetting this. You got me there. There you go. Because it's V equals IR, right? IN times RN, right? There we go. So, let's see, where's my work? Actually, no, this is right here. Let's do this. V Thevenin, right, is equal to I Norton times R Norton, right? What's I Norton? 2, right? What's R Norton? It is 3, right? Oh, that looks a lot better. Nice one right there. Let's do this again because I really wanted to see that. I was really sad when I was like, what the haze? Pooey. 7. Perfect. Let's do it again. Let's see. This right here is 3. Yeah, I like that. Does it bother anyone if I just do that? Yeah, right? 30, 5, 3, 6. I. Step 1, current. Step 2, plus, minus, right? 30 minus 5I minus 3I minus 6. You guys like solving these circuits? This is what they expect you doing in the class. Just think. All right, 30 minus 6 is a lot better. Is 24 minus 8I is equal to 0. I is equal to... Good. But we want Vx. What's the voltage over here? Yep, 30. V is equal to IR. Correct? Let's see. We already know this one right here. This is 15, right? 30 minus Vx. What's Vx? Switch. Woo! You can do it. Did you do it? Is this the answer? You got it?
I don't remember.
It's okay. Let's just believe we got it. But this isn't the answer. This was the answer. So yes, you can do this many ways. You can do it with a KVL and feel happy or sad. I don't know. KCL. You can also do a Thevenin and Norton transformation like what we tried right there. The only thing we can't really test you out is on those pesky signs and numbers and decimals. But was that really fun? Is there any other problems we want to go over? What's another painful problem that we had from the exam today and was it last Monday from the other guys? Huh? Yesterday? What's another hard problem? I feel sad now. Actually, I'm angry. Anyways, no other problems? What are other questions we had? About how to do voltage and Thevenin stuff? Maybe. Have you guys gone over superposition? No, not superposition? You guys want me to go over superposition? All right, let's do this. Plus, let's do this. Yeah, let's keep it simple. Let's see. Let's do 10 volts, 1 amp, right? 1, 2, 3, 4, like that. Let's solve for Vx. I'm just going to put it in the middle. So superposition, I'll tell you this. is basically where you solve the circuit. You want to go over like the KVL and the KCLs of this. So, well, maybe you've seen other scarier ones, but this is a circuit. There's another way we can approach this, and that's by superposition, where instead of treating everything as like just running at the same time, let's actually just solve it for one source being turned on and the other one's shut down, right? So I'm going to tell you this about voltage sources, is that when you want to turn them off, it just becomes a wire. And then all you do is you just analyze whatever your circuit is. What do you call it? Let me just do this. And you solve your circuit for that now. See how this battery now turns into a short? We just turned it off, right? Same thing what we did in LT Spice. It's just dummy. It's just done. Yeah, correct? But when you're solving for these circuits, you're actually solving for a part of a circuit. So I think what I'm going to show you is what I'm going to see. Instead of doing, here's a box with a battery, right, and the current meter, right, in, out, right. I'm just creating some box. It's equal to if you did the following, right? And then plus, or that's a bad plus sign, plus Vn. I'm trying to show you superposition. So basically, instead of doing all of it together, you just add whatever you did with your source and add whatever you did with your current supply. All right? So this right here is just Vx1, okay? We're just, keep that in the back of your head. So if I were to solve for this circuit, this is 1, 2, 3, 4, right? How do I want to do this? Let's draw our ground. You see that parallel resistor, right? Let's do this on another page. 9. Do this, and then what's the parallel resistance between 1 and 2? I don't know. Let's see. 1 times 2 over 3. 0.667 ohms. Right? Is that good? This right here is 3. This right here is 4. Is that good? But we want to solve for Vx1, right? Well, first off, we need to know what the current is going through here, right? So what I'm going to try and show y'all is, let's see. Well, this right here is V. I'm going to call this one VC or something like that. Oh, I don't want to solve for this. First off, this right here is 2. No, this here is 1, sorry. 1 amp going into here. And I want to solve for this. Let's see. Well, I want to know what the voltage is right here. I want to solve for this voltage. So we got 3 ohms right here, right? Plus this 0.667, right? In parallel with that, right? What's that resistance? Or parallel resistance? Let's find out. Calc. All right, anyways, 3.667 times 4 divided by, actually, okay, let's keep that number. 3.667 plus 4, 7.667. Now let me just do this. Do I have S3 calculator? S3 calculator. This number divided by that number. Hello, let me use this number. 14.667 divided by 7.667. Hello. There we go. 1.91 ohms, correct? And all we're left is with this. Oh, sorry. Thank you. Right? What's the voltage over here for VC? Which is equal to I times R, right? Which is equal to 1.91 volts. Is that good? But now we want to solve for Vx, correct? So I'm going to do the following. I'm going to put my ground over here. This one is VC, Vx. All right, let's see. We know the voltage right here, right? But now we want to know, what do you call it? Do I want to solve for my currents? Yeah, I do need to solve for my currents. If this right here is VC, right? What's the current in here, given that this is 4? I'm going to call this one I4, right? VC over 4, right? Boom, got it, right? But then I want to solve for, I'm going to call this one IX, right? If I were to do a KCL, right, of what's going into this node, right? We got 1 amp going into this node, right? I got this amp going out of the node, right? And this one also going out. So if I did a KCL, correct, of what's going into the node, which is 1 amp, right? What's going out of the node is this VC over 4, right? Is everyone understanding where I got this number? Because we just solved for the voltage. I'm just getting the current, right? V over R. Good? Plus the current going here. Let's do this. VC minus Vx over, what do you call it? This right here was 3. Hey, wait a second. This is what we want to... This right here, we know this, we know this. This is the one we're trying to solve for. There we go. Plug and chug. But let's see how much time I got, because I want to show you guys what I'm trying to do. 10. Let's see, I'm going to rewrite this again. If you don't mind, I'm going to do VC over 4 plus VC over 3 minus Vx over 3, right? But I want to solve for Vx. So if I did the following, let's see if anyone's bothered by this. 1 minus VC over VC 1 over 4 plus 1 over 3, right? To Vx, right? Is anyone bothered if I did this? Anyone bothered by that? So all I did was I combined these terms together to get this, right? I put it on this side and it's a minus, right? And I just substituted this, or extra, or put this right here on the side because Vx or VC was already given as 1.91 volts, right? I'm just doing this for calculation purposes, right? Vx is going to equal to, oh gosh, this is going to be a lot. Let's see. I don't want to simplify this. This right here is 3 over 12 plus 4 over 12. Just going to give you, let me just do this. I don't like this. 1 minus VC 7 over 12, which is equal to minus 3 plus 3 VC 7 over 12. Vx 1 is equal to, man, why did I pick these numbers? These numbers are dumb. Calc. Maybe I should have made this a demonstration. 3 times 1.91 times 7 divided by 12. That's that. Minus 3. 0.34 volts. Let's try this. I'm going to show you my cheat way. There's a better way of doing this. Resistor. What did I do? Let's see. Here's page 9, page 8. What was I trying to show you with this right here? Whoa, superposition. There we go. Let me show you what I was trying to do. 1, 2, 3, 4. Current. Boom, boom, boom. That's not in line. Boom, 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 boom. Boom, boom. And move this. This is what I'm trying to solve for, Vx1. Right? This right here is 1, 2, 3, 4. VOC, or not VOC, VC. There we go. Let's solve for this. Current, 1 second. I1. Oh, wait, this is going in. There you go. 2. Did I do this right? Is that correct? Let's see. What? No, wait. 2. There we go. 1.91 volts. Whew. Good. What is this? 0.347? What is that? What I calculated? Yeah, we did it. Oh God, that was painful. So this is one circuit, right? You would do the same thing. If you guys want to try this for homework, let me show you. So it's page 10. To finish this circuit off. Oh, there we go. Plus minus. 1, 2, 3, 4. Vx2, show you this. To solve this circuit for your current source, it's an open. You would solve for this circuit, okay? And then your total circuit, Vx, would equal Vx1 that you found, which was 0.34 volts, right? Plus Vx2, which is coming from this circuit right here. And now you have your full circuit. Is that painful? Yeah, this is another way of doing, this is superposition. All right? Any questions? All right, y'all. Have a good day, everybody.